So we're going to learn about linear programming. Linear programming class is it's a technique used to find out, to optimize a bunch of, what is it? It's a way to find a maximum, usually like a maximum profit of something, or the maximum amount of money you can make when you're investing, or the maximum amount of money you can make if you're building a bunch of thingamajiggies, like chair. You know that problem with the chairs we had, and if each chair you made so much money, or if you're running a store, and say you make so much for donuts and you make so much for coffee, you want to figure out how to maximize your profit. So business people are very interested in linear programming. It came out of World War II, and the bad guys in World War II in Germany used linear programming to make tanks and weapons and stuff like that, and they were very efficient, and it was very successful in making a very strong army during World War II. But anyway, it's a useful technique, and basically what you do is you have a bunch of equations that are constraints, meaning there's limitations on lots of things, like you have so much, in this case you have so much money to invest, right? Or you have to have at least so much invested in this. And then you have another equation called the optimization equation, and that's the equation on which you're trying to optimize, meaning where you're trying to find the maximum or the minimum, okay? So in this one, what you're doing is you're investing some money, and you have two different kinds of bills. You have treasury bills, and treasury bills you can invest in, or my Moby is freezing, or you have treasury bills or bonds. Is that in corporate? What happened to the bonds? It should say where? How did it get over here? So this is kind of messed up. In corporate bonds yielding 9%, how much money should be placed in each investment so that income is maximized? I don't know how this. I could probably fix that. Let me move that. Somehow that got in corporate bond. So this sentence, I could probably do this, right? Cut. Paste. Did that work? There we go, right? That's how it looks on your sheet, more or less. Yes? Okay. So the optimization equation, first what you want to do with each of these is you want to set up your variables. So I'm going to let x equal, and the way you find that is you look at the last sentence. How much money should be placed in each investment so that the income is maximized, okay? So let x equal the amount, okay, the dollars in, what are we investing in? Dollars in T-bills. They call those T-bills, treasury bills, okay? And then let y represent, it was easier to write on the board, but
You should do it on the board.
no, but I want to record this. Let y equals dollars invested. It's invested. Why don't I make this page bigger? Can I do that? I don't want to mess things up. In bonds, okay? Treasury bonds. Is that what it says? Treasury bills, corporate bonds, okay? And notice that the bonds have a higher percentage rate than the treasury bills, and there's probably a reason for that. Anyone know why? Like when you invest stuff, the things that yield higher usually have a higher volatility, like they're more risky, you know? So that's why people say, well, why didn't I just put all my money in here, you know? But that's because they go up and down more. So in the short term, probably in the long term, these things are better, but in the short term, this might be better because it doesn't bounce around as much. You know what I mean? If you're an investor. So the optimization equation looks like 0.06 x plus 0.09 y. And this thing over here is a variable, and we call this p for your profit or your income or whatever you want to put over here. So what you're trying to do is you're trying to figure out how much you're going to invest out of your $25,000 in treasury bills, right? And how much you're going to put in corporate bonds if you have 25,000. So the next thing you do is you write down your constraint equations, and those look like, first one looks like x plus y has got to be less than or equal to something. What does that got to be less than or equal to? 25,000, because that's how much money you have to invest. You know what? I'm going to leave everything. I'm going to leave off the thousands until the end. Is that okay? Because that way I'll make my math easier. Okay? X plus y is less than or equal to 25,000. And then I have another constraint, x. So it says, then you have to look at the next part. It says, at most, you recommend that they place at least 15,000 in treasury bills. So how would I write that? X is treasury bills, so X has got to be greater than or equal to 15,000. So that's another restraint. Whoops, I want 15 instead of 15,000. Okay? And then Y has got to be at most 5,000. What does that mean? Less than or equal to. Okay? Less than or equal to 5. Okay? And then always, well, for most of these, you're going to have two more additional constraints. And one is that x you want to be bigger than 0, and y you want to be bigger than or equal to 0, because you're not going to have any negative numbers in here. Okay? So then using this as my x and y axis over here, okay, I got to pick a scale. Anyone think of a good scale to use?
15,000.
50 per box? No. What? How much should I? If I go count by fives, would that work?
All the way.
Yeah, but then I'm gonna get. It's gonna get. We could count by smaller than fives. We could count by twos.
No, we should do 5s every other box.
Fives. Okay, that's a good idea. That works. Okay, Austin had a good idea. He said count by fives every other box. So that's 5, 10, 15, 12, 15, 20, thank you, 25, and 25. 25 comes after 20, okay? And we could do the same thing down here. That's a good scale. 5, that's a 5. Can you see that? 5, 10, 15, 20, and 25. And then I graph these equations. So, and this is dollars, this is, what is this on this axis? Y, this is the y-axis. So this would be bonds in, something like bonds in $1,000, right? In $1,000, and this is T-bills in $1,000. You don't have to do all that, but T-bills in thousands, okay? And so then you want to graph all these inequalities. So x plus y is less than or equal to 25. What's the y-intercept going to be? 25, right? So you could, like, these are set up in standard form, so it's easy to say if x is 0, what would y be? If x is 0, y is 25. So you could put a point right there, okay? And when y is 0, x is 25, right? If I were to make a little table of values for this equation. So I'm going to graph that equation, and I'm going to use a line, and I'm going to make it solid. I'm not going to put any arrows on the end. I'm going to make it solid, and I'm going to make it colorful. What color should I make it? Purple? Sure. And I'm going to go from here to here. Jess? Get that? And am I going to shade above or below this line? below it. But I'm going to worry about that later. And I know that because if I were to plug in the point 0, 0, 0 plus 0 would be less than 25, so I'm going to shape below. What would x is greater than or equal to 15 look like? Come over here to 15, right? And do a straight line from up like that. Try to go something like that. And what would y is greater than or equal to 15 look like? Wait, sorry, y is less than or equal to 5. Straight line across that 5, right? So I'm going to go straight across by 5. And then, so where is the spot that is less than this, and greater than this? What are we talking about? Because it's got to be bigger than 15, right? Less than 5 in the y, and less than this line. So do you understand that you would be right in here? Okay? So that, whoops, I'm not very good. I didn't get a very good grade at coloring in between the lines. But this here is called, this has a name, okay? And this is called the feasible region, right in there, okay? So this area is called the feasible region, and that is the place, any point in that region will make all of these inequalities true, okay? Have you done this before?
Yes.
Oh, good. All right. And then what the special thing about linear programming, what they discovered, these evil Nazi you-know-whats, okay, what they discovered is that, no, I don't know, it was the Germans, some German guy is responsible for developing. But I don't know, I think they did say that the Nazis used it during World War II though, okay? But anyway, these 4 points, what linear programming says is that the maximum and the minimum are going to occur at these critical values. Okay, what are they called? Not critical values. They have a name. Sorry, I forgot the name of them. I forget what they're called. I have that somewhere. Feasible. Oh, those are called the feasible points. Okay? So what you have to do is figure out what all those points are, and then plug them into your optimization equation, and you see which one gives you the best answer. All right? So I am going to take a picture of this, because what happens is then I can only move down if I have a picture of it. I haven't figured this part of this out yet, but if I go like this, then can I go like that? No. What does this do? Oh, that's kind of cool. That's no, there. Wait, what did oh, I see what I did. That's bad. Let's go back. What does this do? Is this where I was before? Let's just leave it like this. Okay, so what I want to do is make a little table, okay? So I'm going to come over here, and I'm going to draw a picture of a table, okay? And no, that's not what I want to do. I want to make a table, and I want to plug in values at those critical points. I'm going to go X, Y, and P, because that's what I'm trying to find is the maximum profit, okay? So, and I plug in these 4 values. So do you understand that this 0, 0, this is going to give you hardly any, this is going to give you no profit, right? So I'm not even going to worry about that point. I am going to plug in this point, which is 15, 5, okay? 15, 5. And I'm going to plug in this point. And normally if that didn't line up right on the perfect crosshairs like this one, you would have to solve this system of equations to find that point, or use your graphing calculator to find that point. But in this case, it's pretty obvious that that point is what? 20, 5, right? And that this point over here is 25, 0, right? So don't automatically assume that one of the points is better than the other, because if it was really good to, if bonds had a really high return, right? If you're looking at this, where's corporate bonds? If bonds yield like 20% or something, you would probably want to put all your money in there. You see what I'm saying? Okay, so don't assume that this is not the best point or that this is not the best point. You really have to plug in all three of those points. So when I plug in 15 comma 5, 15 times 0.06, what's 15 times 6? 90. Okay, okay, so I get 15 times 6 is 90. Move the decimal place, so I get 0.9, right? Plus 15 times 0.09 is, what is that? Quick. How much? Did I do that wrong? Huh? X is 15 times 0.06, right? Oops, and 5 times 0.09 gives you 0.45, right? And then, sorry about my bad picture. And then I add those together, and I get 1.35, right? And that's in thousands of dollars, so you have 1,000, is that right? Thousands of dollars, so if that's $1.35 thousand, that would be $1,350, yes? Okay, using that point. Using this point, I get 20 times 6, which is 1.2, right? 20 times 0.06 gives you 1.2, and 5 times 0.09, which is again 0.45, so I get, sorry, it's so squished, so I get 1.2 plus 0.45, which gives you out $1,650. Okay, 1650. Am I doing that right? And this point here gives you 25 times 0.06, which is 1.5, right? 1.5, which would be $1,500. Okay, 1,500. This is not very good. Okay, so which is the best point to use? 25. So you should go back to the old retired people and tell them you should invest $20,000 in what? In T-bills, and invest $5,000 in bonds. Okay? And that's the way it works. Got it? Got it. It's kind of the same, but it's more confusing on how to figure it out. Okay? So look up here, please. Lift your heads up. I'm going to say your name on the video, you with the glasses, so pay attention. At the end of every month, after filling orders for its regular, this is confusing. For its regular customers, a coffee company has some pure Colombian coffee and some special blend coffee remaining. So the Colombian coffee is like the good stuff, okay? And the special blend is like the cruddy stuff. The practice of the company has been to package a mixture of 2 coffees into 1 pound packages as follows. A low-grade mixture that has 4 ounces of Colombian coffee and 12 ounces special blend. A high-grade mixture containing 8 ounces of Colombian and 8 ounces of special blend. A profit of 30 cents per blah, 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 and so on and so forth. So I think what I'm going to do is take a picture of this and put it on graph paper. I think that might be work better. So if I take a picture and put it in here, and then I hit graph paper, see, that might work. Good. Where are you going? Thanks. All right. Maybe that won't work. I'm going to make this a little smaller. Then I can do that. So your optimization equation, you kind of look down here, okay, and it says how many packages of each mixture should be prepared to achieve a maximum profit. Assume that all packages prepared can be sold. So you have a high-grade mixture and you have a low-grade mixture. Okay? So you're going to let X equal packages, packs of some constraints. Okay? You know that, I'm just going to go through this. For the low-grade mixture, here I go. So, getting back to this, you have some restraints or constraints, and one of the constraints is that this month there are 120 pounds of special blend coffee left over and 100 pounds of pure Colombian coffee remaining. So what you know is that something is less than or equal to 100 pounds of Colombian coffee times, I'm going to multiply this by 16. And the reason I'm doing that is because all these things are in ounces, and I want to stay in ounces. So this is for my Colombian coffee, okay? Colombian. I have one set of restraints. That's 100 times 16, okay? And so the first one, the first mixture uses, how much Colombian does it use? 4 ounces of Colombian. So it uses 4 X, and the second mixture uses 8 ounces of Colombian. So that's plus 8 Y. Okay? Yeah, you would think that that's where I got confused too. You would think it's 4C plus 12Y, but it's not, because this is the ounce. X and Y are the packages of the low-grade mixture and the high-grade mixture, not of the Colombian and the other one. So this is very confusing in that sense, okay? So 4X, so use how many ounces of Colombian does the low-grade mixture use, and how many ounces of Colombian does the high-grade mixture use, and the restraint is how many ounces of Colombian coffee do I have altogether, okay? Now with the other mix, with the what's the other mixture called? What's the other coffee called? Special blend. With the special blend, okay, you have 8 ounces of, 12 for the first mixture, right? Sorry. 12 for the first mixture, and then you have 8 for the second mixture, right? And that's got to be less than or equal to, you have 120 pounds of special blend. So that's 120 times 16. See that? Good? And then your other two restraints are X has got to be greater than or equal to 0, and Y has got to be greater than or equal to 0. And I'm going to graph these. Is that okay if I graph these? Sure, go ahead. So let's do it. Why are we multiplying by 16? Because this is in pounds and this is in ounces and these are in ounces. You see? So we want to change everything in ounces. Okay, so graphing this first one, 4X plus, and I figured out after trial and error, that a good amount to count by in this problem is 40s. Okay? 40, 80, 120, 160, and you kind of have to play with those windows to figure that out. There would be 200, 240, 280, 320, 360, 400, right? Okay? And this is what I'm just going to call this, since I'm in a rush, I'm going to call this X, and this Y, and then I'm going to use the same scale down here, okay? That's 40, 80, so 5 boxes would make 200. 1, 2, 3, 4, that's 200, and 5 more boxes would make 400. 1, 2, 3, 1, 2, 3, 4, and that's 400. Okay? And then I'm going to graph this one. So up here, I have 4X plus 8Y. So in this little, I'm going to rewrite it up here. 4X plus 8Y, 8Y equals, I'm going to multiply that up together, 1600, or is less than or equal to 1600. If I make a little table here of x and y's, when x is 0, what's y? What's y? 200, right? When y is 0, in this one, what's x? 400, okay? So when I graph this one, it goes to 0, 200, which is up here, and 400, 0, which is down here. And I'm going to take my line tool, and I'm going to graph that in green because it's good copy, okay? There's that one, all right? And then the next one is right here, and that one, when I write it with the thing multiplied out, is 12x plus 8y is less than or equal to 120 times 16. I think that's 1920. Did someone do that real quick? Is it 1920? 1920. And then I'm going to make a little xy table, okay? When x is 0, could someone divide 1920 by 8 for me? Quick. 240. And when y is 0, x is how much? 160. Okay, so for this next equation, I have 0, 240, which conveniently fits right on my scale, and 160, 0, which goes over here, okay? And then I'm going to graph that one, which goes down like that, okay? And then we have x bigger than 0 and y bigger than 0, so my feasible region is going to be where? Right here, right? Right in that little funny shaped looking thingy. That's not really a trapezoid, it's just some kind of quadrilateral. And my feasible points are right here, here, and here. Okay? And then, how come I didn't turn blue? I wanted it to turn blue. Anyway, you get the, oh well. So this point right here, and then I'm going to do the same thing I did in the last problem. I'm going to make a table, okay? And I'm going to put x, y, and p, okay? And for this x is easy, that's 0. For this y, it's 200, right? And we'll do the profit in a minute. For this one, it's, that was 160, right? 160, comma 0. Now to find this point right here, I'm going to do a little bit of algebra real quick. I'm going to subtract these two equations. So I'm going to subtract this one from this one. When I do that, I get 8x equals 1920 minus 1600, which is 320. So x is what? 40. Do you understand what I did? I just took this system of equations and I subtracted them to find the point of intersection. So this one is 40 comma something, and that something I get by plugging back into one of those original equations. And what do I get? I get to be that, so if I plug in 40 in here, I get out 160. What's 8 into 1440? 180. So I get out 180. All right. And then I take those 3 points and I plug them back into my profit equation. And this one's going to give me a profit of 0.4 times 200, which is that $80? No, $80? $80. And this one's going to give me a profit of 0.3 times 160, which is $48, okay? And this one's going to give me a profit of 0.4 times 3, which is $12, plus 0.4 times 180, which is $72. So altogether, with that one, I get $84, which is my point that I want to use, okay? So how many ounces of each do I use? Or how many packages, 40 packages of the the low grade and 180 packages of the high grade. The end. Yay.
Thank you.